Okay, today we are going to look at how to calculate takeoff and landing distances. These charts can be very daunting. So, this chart actually has three different sections, actually four different sections. The first section is the outside air temperature section. The top is the Fahrenheit, the bottom is the Celsius. Once you have the temperature, the next are the pressure altitude curves. 10,000 feet, 8,000 feet, 6, 4, 2, and 1. So that's the first part of it. If you notice, the top part has Fahrenheits, pounds, the weight of the aircraft in pounds, the wind component in meters per second, the obstacle in height from 0 to 50, and then the takeoff distance, and then the takeoff distance with a 50-foot obstacle calculation. On the bottom, you also have the outside air temperature in Celsius, which is what every single METAR will give you. And then you have the weight in kilograms. And the bottom also has the wind component in knots, which is what you need. And then from 0 to 15 feet in meters. And then again, the takeoff distance and the takeoff distance with a 50-foot obstacle. The same thing can be repeated for a landing distance with a 50-foot obstacle. The idea is that every force is equals to mass times acceleration. So when you take off, there's a certain amount of ground distance that you will cover. That depends on how fast you accelerate and what the takeoff distance is. On a colder day, with aircraft performance being better because cold air is more dense, the propeller or the thrust produced is more than on a warmer day. Therefore, better performance, shorter takeoff roll. On a colder day, better performance, therefore a shorter landing roll. On a warm day, since the air is warm air has more energy, therefore it is less dense. The performance is not that great. So longer distance to take off and longer distance to land. And that's what we're trying to figure out. So what will always be given, you will have to have, they'll give you the pressure altitude. You'll know your outside air temperature. Well, pressure altitude can be figured out, right? It's non-standard temperature corrected for, or non-standard pressure corrected for the true altitude corrected for non-standard pressure. So if pressure altitude not known, can be corrected. For the purposes of the knowledge validation, the pressure altitude will be given. Outside air temperature will be given in Celsius. The weight of the aircraft for our purposes is going to be given in pounds. And the component, the headwind component or the tailwind component will be given. Now, in this case, the pressure altitude is 2,000, so we go to the 2,000-foot line. The outside air temperature is 15, so we come to the 15-degree line. So from 15 degrees, we come to the 2,000-foot pressure altitude. Once we get to the 2,000-foot pressure altitude, we go straight across to the weight. Well, what is the weight of the aircraft? It's 2,200 pounds, or in this case, 1,000 kgs. So we come down to the 2205, 2,205. See, 2,205. So we come to the 2,205 kgs. So from here, we come straight down to the 22.5. Once we've got the weight, then we go straight across. Then the wind component was 10 knots. 10 knots, so we come to the 10 knot wind. Where it intersects, we go straight across. Now, once we have gone straight across, we come straight across, and you can read 188 meters, or in this case, just above 598, so just under 600 feet. So come straight across in feet to read your takeoff distance. From here, straight across to reach a takeoff distance, which is just under 600, which just gives you 598. If you want to know your takeoff distance with a 50-foot obstacle, well, then you take this part and then go straight up, and then you go straight across, which is just about 1,100 or 1,000 feet right here. Okay? To see this in a better way, you can also come back and look over here again. So our takeoff distance was 15 degrees Celsius was our temperature. Pressure altitude was 2,000 feet. We came straight across. Once we got here, we came to the weight of the airplane, which was 2,200 pounds, which was given. Then we go straight across, and then we come to the 10 knots. If it was just 5 knots, we would have come up here, but it's 10 knots, so we come down here. If it was 15, we would have come all the way down till it intersected this line, and we would have come this way. But the 10 knot wind, so we stop at the 10 knot intersection. Once we come here, you go straight across, and when you read right up here, okay, if you're looking at this part up here, hey, what is that? Well, this part up here, that's for the maximum gross weight. So this one, they didn't take the weight of the aircraft at all. They just went straight across, came down to the 10 knots, and then came up straight. So without actually looking at the weight, it's 850 feet of takeoff distance. With a 50-foot obstacle, it's 1,260 pounds. But for a 2,200 pound airplane, you come on a 10 knot, on a 15-degree day, 2,200 pound airplane, 10 knots of wind, you come straight across. So once again, 15 degrees, 2,000 feet of the pressure altitude, you come straight across. The weight of the aircraft is 2,200 pounds, which is given to us. So you come down here, which is either 1,000 kilograms, which is 2,200 pounds. You come here, then you go straight across, and then you come down to the wind component, which is in this case was given to us at 10 knots, and then you adjust, and then you come straight across, and this is in meters and this is in feet, and you reach 600 feet for the takeoff distance. Takeoff distance with a 50-foot obstacle, you go from up here to straight across, and you read 1,000 feet straight across, 1,000 feet. And the same thing, that's how you read these charts, and that's all there is to it.